Last week we talked about the basic graphs of sine and cosine, of tangent, cotangent, of cosecant and secant, and we learned the features of those graphs. Now we're going to learn how to do vertical transformations and horizontal transformations, and maybe even if we put the amplitude changes and it changes like the compression or stretches of a graph. So I want to just state this as we're going through these graphs, and if you want to check your answers, and I recommend that, you can use your graphing calculator if you have one. If you have access to one. I check mine with my TI-84, but I didn't require you to get one for this course, so you don't have to have one. You can go to a free online calculator called Desmos.com, and Desmos.com, and just start graphing, and you just type in your equation and it will put the graph up there, and you can check to see if you are getting the correct answer. So I just wanted to make sure I mentioned that. So let's begin. The things that we're graphing in section 3.2 are sine and cosine of this form, k plus a sine of bx or k plus a cosine of bx. So let's talk about what these different features mean. K right here, this number, is just when they've tacked on a number to a graph, and that is a vertical shift up and down of a graph. So if k is positive, which can be written like that, you go up k units. It shifts your graph up k units. If k is negative, it goes down k units. Okay, so let me just remind you from college algebra what that looked like. If you had a graph, say, the absolute value of x, we know that this graph looks like this. But if you had the absolute value of x plus 2, we know that would just take this guy and shift him up 2 units. But it didn't change the shape of the graph. Or if we have the absolute value of x and we shifted it down 3 units by minus 3, that would just go 1, 2, 3 down 3 units, and it doesn't change the shape of the graph. So this is what this k is doing. Lots of times they'll tack the k on this end of the equation, but they can also put it in the front because commutative for addition exists, and you can add something at the beginning or you can add something at the end. So that's what this k is doing. All right, what is the a right here doing? The a is the amplitude. And so what the amplitude is, it's how high and low a graph will toggle between the midline. So if x is the center of our sine and cosine, it's going to go up a and down a, up a and down a. If a is negative, if a is negative, if it's a negative number, then that is indicating a reflection across the x-axis. Reflect across the x-axis. So let's have a look at what that might have looked like in college algebra. If this is our basic graph, the absolute value of x, but they said, I want you to graph this, and they put a negative in front of this. That's like if our a is negative, what that's going to do is cause it to reflect across the x-axis right here. So that's what we would have. So if a is negative, we're going to have to shift our graph across the x-axis. What does b do? B affects the period. It affects the period, which tells us if we will accomplish one sine wave in, let's say, one sine wave goes to here. If we accomplish this in the regular 2 pi period, 0 to 2 pi, or if we accomplish that in pi over 2, it only takes us that long, or if it takes us 4 pi, okay? B affects that, and how we can figure out exactly what that's going to do. And so that's kind of like a shrinking, a horizontal stretch and shrink like that. But how we can figure out what B is going to do, how it's going to affect it, is for sine and cosine, which is the graphs that we're on right now. For sine and cosine, the period is 2 pi. So if B is 1, the period is still 2 pi. But if B is not 1, it affects the period. So how we can figure out the period for our function is to take the number in front of the x, which is the B, and take 2 pi and divide it by that, and that will tell us our period. There's another word on here, spacing, we're going to need to know. The spacing, which we probably talked about when I introduced these, the spacing can always be found by taking whatever we got for this period, take the period, and divide it by 4. So in general, this is how these little working parts work. So we're about to dive into this, and as we do a few examples, it's gonna make sense to you. So this is what they said. They said graph this over this interval, and this looks like a 1. This is really a pi. And so another thing I'm trying to do as I go through these videos is go a little bit slower to make sure that I'm happy with my answers and that they're correct, so that we don't have to worry about you guys seeing things that are not correct. So that might take a little longer, and I apologize for that. I think when I first started online, I was trying to make my videos short because that's what everybody said, and maybe I was going through them too fast. So I'm going to make sure that we are getting the correct answers out. So this is our function. Y is equal to 3 cosine of 2x. And so you always take the sine or the cosine of an angle. So 2x is our angle. When we look at this, we can compare it to this equation. Y is equal to k plus a cosine of bx. So what do we notice here? We notice that we don't have anything being added to this. Basically, we just have this part. What that means is that k is 0 and that there is no vertical shift. That's what that means. So I'm just going to erase that part because it's 0. We don't have to look at it. Then let's just compare things. What would we say the amplitude is? Well, the amplitude is the absolute value of whatever we see right there. A is 3, and so absolute value means how far from 0 the amplitude is 3. So whatever our sine looks like, it's going to go up 3 and down 3 from the middle of the graph. The period is always equal to 2 pi over b. So in this case, it's 2 pi over the number we see in front of the x, which is a 2. So that's pi. The spacing is always the period divided by 4. So in this case, it's pi over 4. Now the spacing, the big deal about spacing is that's what tells us how to slice up our x-axis. That's a really big deal. And so we know we're going to start dividing it up in pi over 4. Is there a reflection? In other words, is there a negative in front of the a? And there's not. This is a positive number, so there's no reflection. The range I'm going to write down at the end. Okay, I'm going to write that in interval notation. So let's begin to graph. We take note of these things off of the equation we're given, and then we start to slice up our axis in these little intervals. Pi over 4. So this is 0. To the right, I'll go pi over 4 plus another pi over 4 is pi over 2. I'm going to label it down here because I don't want it to be in the way of my graph. Plus another pi over 4 is 3 pi over 4 plus another pi over 4 is pi. And I had to go all the way to the right of pi. Now, I'm going to go backwards that same amount. Negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative pi. All right, and so now I want to graph this. How high and low? Well, normally it would go between 1 and negative 1, but the amplitude is 3. That means I'm going to go up 3 and down 3. So on my y-axis, I'm going to go up 1, 2, 3, and down 1, 2, negative 3. All right, so if you recall, this is the thing you want to keep in mind. Cosine and sine, these are the two that we really, really want to get good at this. Cosine typically starts high, right? And we're looking at a cosine graph, so it starts at 1. the cosine of 0 is 1. So instead of being 1, it's going to be 3. And so it's going to start high, but instead of starting high at 1, it starts at 3 because the amplitude code changed. And then we just follow our pattern. Here are our 1, 2, 3, 4, 5 important points. So it goes high, middle, low, middle, high. And then we can backtrack. This is going to go middle, low, middle, high. Okay, and so this, we just connect our dots in a smooth curve like this. And we realize that this will go on forever because it's periodic. One period, it took us from 0 to here, pi, to complete one cycle. So the period got adjusted because of that. B is 2. All right, I'm just going to double check to make sure that I'm happy with this answer. And it looks like I've got everything where it ought to be. Okay, I like that. I have not called out the range. Let's call out the range. The lowest point is -3 and the highest point is 3. So in interval notation, this is from -3 to 3. So that's number 1 on your little worksheet. Okay, now let's head into number 2. I'm going to move it over here. Let's do number 2. Goes like this. And so what I'm going to do is I'm going to share these words right here with number 2. I'll do it in purple. Okay, so my graph will be in black. This is number 2, and number 2 is y equals 2. 1/2 the sine of 2x, 2 pi x. 1/2 the sine of 2 pi x. And it's supposed to be over the interval -2 is less than or equal to x is less than or equal to 2. So we want to go from -2 to 2. Just look at that. I write my 2's 2 different ways. It doesn't mean anything special. It just means they're both 2's. So I don't know why I write them differently sometimes. So, all right. So this is the graph we're given. I'm just going to go ahead and draw my little grid. You guys already have your grid. All right, so this is what we need to do. We need to compare this function with y equals 2 a sine of bx. Okay, here we go. Let me make sure I wrote it down right. Yes, 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 yes. Okay, I'm happy with that. What do we think the amplitude is? Well, it's this number in front. The amplitude here is the absolute value of 1/2 or just 1/2. What do we think the period is? Well, the period is always 2 pi over b. But what is b? b is 2 pi. So 2 pi divided by 2 pi is the number 1. So the period is 1 unit. What is the spacing? The spacing will be the period 1 divided by 4. Is there a vertical shift? Do you see this little k somewhere on there, plus k? I do not. So that means k is 0. So this means that there's no vertical shift. Is a negative? No, that means there's no reflection. And then we'll put the range in at the end. Or first, let's cut up our x-axis in 1/4. So 1/4, 1/2, 3/4, 1. I might have to make this longer. And I'm going to label all this too. All right. So this was 1/4, 1/2, 3/4, 1. Another 5/4. Another fourth is 5/4. Another fourth is 6/4 or 3/2. Another fourth is 7/4. And then another one would be all the way to 2. These are kind of getting mixed in here. So let me see. This is the amplitude is 1/2. All right, on the left. Ooh, I might have to go out wider. Poor planning. Okay, here we go. 1/4, 1/2, -1, -3/4, -1, -3/4, negative 1/2, negative 1/4, 1, 2, 3, 4. It might be a little squished on this side. Negative 2, negative 7/4, negative 3/2, negative 5/4 is that one. Okay, so I put my labels down low so that doesn't get in the way of the graph I'm about to do. Now, how high and low are we toggling? The amplitude is 1/2. So if this is 1 and this is negative 1, then we're going to be going up here to 1/2 and negative 1/2. That's how high and low. It won't go as high and low this time. Okay, so let us begin. Where does sine typically start? Sine does not start high. Like cosine, it starts in the middle. So let's start in the middle, and then we'll just lay it out. Middle, high, middle, low, middle. Go again. High, middle, low, middle. We can go backwards. Let's see. Middle, low, middle, high, middle, low, middle, high, middle. Then we can just connect our little sine wave like this. And there we go. And we know this does not stop there. That's just the interval over which they wanted us to graph it. So, real quick, I want to make sure that I did not make mistakes. Let's see. It looks okay to me. So, I'm going to say yes. Now, the range, I did not do the range. What's the lowest point that this graph hit? It hit negative 1/2, or if you want to think of this as negative 0.5, either way, to positive 0.5. So that means I could write negative 0.5 to positive 0.5, or negative 1/2 to positive 1/2. Okay, so I want to point out two things before we do the next thing. Look at the line about which it goes high and low. It goes up 1/2 and down 1/2, up 1/2 and down 1/2. That's called the midline. And so in this example, the midline was the x-axis, so I'm going to write down the midline for the purple is y is 0, which is the x-axis. In this case, it was the same. We did not have a vertical shift in this, either one of these, so the midline remained the x-axis, which is, just take note of this, the midline was y equals to 0. All right, that's our first two examples. Let's look at a couple more. Let's see. I think the next two might have a vertical shift in it, so we can see how that plays into all of this. All right, so this is what we're doing. Okay. So number 3 says to graph y is equal to, number 3, let's do 3. 3 says to sketch y is equal to negative 3 times the cosine of x over 2 plus 1 over the interval negative 4 pi is less than or equal to x is less than or equal to 4 pi. Okay, here is my axis. And the things I want to talk about are the amplitude, the period, the spacing, the vertical shift, is there a reflection, and the range. And so I'm going to do what I did before. I'll do one example on the left and one on the right, so I don't have to write those things down again. Okay, so for this graph, we'll do this one in purple again. Okay, so let's make a comparison. This looks like sine or cosine. This looks like cosine because I see cosine. And so this has k plus a cosine of bx, and this has a cosine of bx plus this number 1. 1 is the k. And this time they didn't write the 1 in front, they wrote it in the back, and that is, sometimes that will happen, that's no problem. But we recognize that this is what k is. Then we compare it with a. A is negative 3, okay? And you heard me say that negative, this means there's a reflection. And then what is b? B is whatever's in front of the x. And so sometimes this is hard to spot, but this is a 1/2 times x. So 1/2 is in front of the x right there. All right, what is the amplitude? The amplitude is the absolute value of -3, so it's 3. What is the period? The period is 2 pi over b, or 2 pi divided by 1/2. We can do a keep, change, flip. This is 2 pi over 1 divided by 1/2, or times the reciprocal, 2 over 1. So the period is really 4 pi. That's what the period is. What is the spacing? The spacing is the period, 4 pi divided by 4. So the spacing is going to be pi. That's how we're going to split up our x-axis. Is there a vertical shift? Well, yeah, k is 1, indicating we're going to go up 1. We have to deal with the vertical shift this time. Is there a reflection? A was negative, so yes, there is a reflection. It's going to reflect across the x. And then the range we will call out at the end. Okay, let's go ahead. Begin by splitting up your x-axis. And so the interval is from -4 pi to 4 pi, but the spacing is pi. That means I'm going to lay out these important points. 1, 2, 3, 4. But this time, these are going to go by pi. This is 2 pi. This is 3 pi. This is 4 pi. And we'll go backwards in the negative. -1, -2, -3, -4 pi, -3 pi, -2 pi, -pi. Okay, so then how high and low are we supposed to go? We're going to go up 3 and down 3. All right, so let's mark that. 1, 2, 3. 1, 2, -3. Okay. Do we have a vertical shift? We do. We'll handle that at the very end. Okay. Is there a reflection? We're about to handle the reflection. So, how we would start with cosine. Does cosine start high or in the middle? Cosine starts high and sine starts in the middle. So, here we go. If this starts high, but it's reflected across the x, instead of starting high, it will start low. So, this is how we deal with the reflection. We begin low, and then we go middle, and then we go high, and then we go middle, and then we go low. And then we can follow it this backwards. Middle, high, middle, low. And so this is our graph. So let's connect the dots. Now, I have not handled the vertical shift yet. So here comes the big deal, the vertical shift. It is shifted up 1. What I'm going to let you do, because this is the type of graphing I want you to do, similar to what I'm practicing, that's what I'd like to see from you. How you can handle a vertical shift is realize that this picture gets shifted up 1. This is how we're going to indicate that. We're going to go to our y-axis and add the number 1 to each of these. So really this is a -2, this is -1, and this is our new x-axis. This is our new x-axis. This is 0. That means this is 1, this is 2, this is 3, and this is 4. We're going to change our axis. Now, I do want to call out the midline. The midline is y equals 2. See, this is the midline right here. Up 3, down 3, but it's the line y equals to 1. It will be what your vertical shift is, y equals to 1. And so if you graph this on your graphing calculator or on Desmos, what you're going to see, here's the x-axis, and more of the wave is above the x-axis than is below the x-axis. So what is the range? The range is from -2 up to 4. All right. That's an example of a reflection and a vertical shift. Here's one more. Number 4 goes like this. Oh, wait, let me double check. Midline that. Range, did I miss anything? Up 4, down 2. I think that one's okay. Good, okay. Here is number 4. And so this one is y equals to -1/2 plus 1/2 the sine of 2 pi x, And this is from -2 is less than or equal to x is less than or equal to 2. And so let me draw my grid right here. And let's talk about what we've got going on here. All right, what do I see here? This looks very, very much like this right here. Y equals to k plus a sine of bx. So what is k equal to? K is -1/2. Okay, what is a equal to? A is +1/2. What does b equal to? B equals to 2 pi. All right, so let's go through and label these. The amplitude is equal to the absolute value of a. So 1/2 is 1/2 from 0. So the amplitude is 1/2. Is a negative? No. So that means there is no reflection. But k is negative, so that means it's a vertical shift down 1/2. So is there a vertical shift? It's going to go down by 1/2 unit. All right, what's the period? The period is equal to 2 pi divided by b, but in this case it's 2 pi, so that's the number 1. The spacing is always the period divided by 4, so the spacing in this case will be 1/4. I feel like I should change colors so I'm going to say the same things. I'm going to write down the same things, but I'm going to make it green so that we don't get these, so I don't get these mixed up. So let's see, I'm going to make you green, green, green. Oh, that's a B. That's A. Okay, and that's K. All right, so the amplitude we said was A is 1/2. The period we said was 2 pi over b, but in this case that's 2 pi, so the period is 1. The spacing is 1/4, okay. The vertical shift is right here, down 1/2. Is there a reflection? Well, A is positive, so no reflection. And then we'll deal with the range at the end. Okay, so here we go. How do we begin? We begin by splitting up our x-axis. So we're going to split it up into 1/4. We have to go all the way to 2 and all the way back to -2. So I might need to make this longer. So let me see. Alrighty, here we go. 1/4, 1/2, 3/4, 1, 5/4, 3/2, 7/4, 2. And the negatives. -1/4, -1/2. -3/4, -1, -5/4, -3/2, -7/4, -2. All right, so we labeled that. Now, how high and low are we going to go? 1/2 and 1/2, right? So that's our amplitude. So if this is 1 and this is -1, then this is 1/2 and this is -1/2. Okay, so our graph is sine. Does sine start in the middle or high? Sine starts in the middle. So we're going to start in the middle, right here. And then we're just going to go with our increments, middle. Then it goes. And there was no reflection, so that means we go high on our next move. If there was a negative in front of the A, which there's not, but if there was, then we would go down on our next move instead of up. But there's not, so we go up. So it's ready. Middle, up, middle, low, middle, high, middle, low, middle, and we can go backwards. Middle, low, middle, high, middle, low, middle, high, middle. We can connect our points together like this. That is our graph. But I have not handled the vertical shift, which said we need to go down 1/2. So let's handle that. You can go to your y-axis and you can just subtract 1/2 from every point. So that means 1 up here was 1 minus 1/2. This becomes 1/2. So let me do a different color now that I've changed this. This is the change. It's going to be 1 minus 1/2 is 1/2. 1/2 minus 1. Oh, the red is weak. Let's see. And this was 1/2 minus 1/2. This becomes our new, right here, this becomes our new x-axis. This is our new x-axis. This is 0. 0 minus 1/2. This is negative 1/2. This becomes negative 1. This becomes negative 3/2. All right, so what is our midline? Let's talk about what the midline is. The midline was the x-axis, but that got shifted. So it's now y equals 2. The midline is